In this video, we are going to be looking at some formula that can help us with our probability questions. We're going to use the probability of A given B, and the formula for that is the probability of A and B, the intersection, the chance of them both happening, divided by what's given, which is, in this case, the probability of B. If it was the probability of B given A, it would be the intersection of them both, the probability of A and B, divided by what's given, which in this case would be the probability of A. Another formula we've got is the probability of A and B, the intersection of A and B, is the probability of A plus the probability of B minus the union of A and B. And we can add the union of A and B to both sides, take away the intersection, and another version of this formula is the probability of the union of A and B is the probability of A plus the probability of B, take away the intersection of A and B. So these are the formulas we're going to use, and they're going to help us answer these questions. So the first question, we've got A and B are two events. The probability of A is 0.3, the probability of B is 0.4, and the probability of A given B is 0.5. Find the probability of A and B, the intersection of A and B. So if we use our given formula, the probability of A given B is the probability of the intersection of A and B divided by what's given, the probability of B. And we know the probability of A given B is 0.5. We want to know the intersection, and we know the probability of B is 0.4. So the probability of A and B is 0.5 times 0.4, half of 0.4, 0.2. Find the probability of the union of A and B. So that's going to be the probability of A, which is 0.3, plus the probability of B, take away the intersection of A and B. So 0.7, take away 0.2, 0.5. Questions for you to try? Give them a go. A and B are two events. The probability of A is 0.2. The probability of B is 0.5. The probability of B given A is 0.75. Find the probability of A and B, the intersection of A and B. So the probability of B given A will be the intersection of both of them, divided by what's given, which is A this time, probability of A. So 0.75 equals the probability of the intersection of A and B divided by 0.2. So what's the intersection? It's going to be 0.75 times 0.2. And that's going to be 3/4 of 0.2, 0.15. Find the probability of the union of A and B. So that's going to be the probability of A plus the probability of B, take away the intersection. 0.7, take away 0.15, will be 0.55. Okay, we've got another question here. A and B are two events. The probability of A is 0.38, probability of B is 0.42, and the union of A and B, 0.7. What's the intersection? So that's going to be the probability of A plus the probability of B take away the union of A and B, and that will be 0.1. Find the probability of A given B, and that's going to be the intersection of A and B divided by what's given, which is B. So 0.1 over 0.42. Let's simplify that. And that's 5/21. 5 over 21. One for you to try. See if you can give it a go. So this time we've got the probability of A given B, the probability of B, and the probability of the union of A and B given to us. So we want the intersection. Let's use our given formula. So the probability of A given B is the probability of the intersection of A and B divided by what's given, which is the probability of B. So that's 0.4 equals the intersection divided by 0.25. A quarter times 0.4 will be 0.1. We want the probability of B given A. Now, we don't actually have the probability of A. It's sometimes useful to sketch a Venn diagram. So what do we know? The intersection is 0.1. B is 0.25, another 0.15, and the whole union is 0.6. So outside 0.4, we've got 0.25 so far. We need another 0.35. So now we have all the information. So the probability of B given A is the intersection divided by what's given, which is A, and the whole A circle is 0.45. 0.1 over 0.45 is 2/9. And one more question. A, B, and C are three events such that the probability of A is 0.4, the probability of B is 0.6, the probability of C is 0.1, and the probability of A and B, the intersection, is 0.2. Given that A and C are mutually exclusive, so they can't happen at the same time, they've got no intersection, and B and C are independent, find the probability of B, the intersection of B and C. So if they're independent, the probability of B times the probability of C will be the intersection, probability of B and C. So the intersection of B and C is 0.6 times 0.1, which is 0.06. So that's the intersection. Find the probability of not C given it's B. So the probability of not C given it's B. I'm going to sketch a Venn diagram. A and C are mutually exclusive, so they can't happen at the same time. There's no intersection between A and C at all. So it's A, B, C. There's no intersection between the A circle and the C circle. And what do we know? We know the intersection between B and C is 0.06. C in total was 0.1, so we need another 0.04. We don't know the intersection between A and B. We do, it's 0.2. So we know the rest of A is 0.2. And we've got 0.26 in B so far. We need another 0.34. And The whole B circle is 0.6, so 0.6, 0.8, 0.84, 0.16 on the outside. Okay, so we've got all the information. We want the probability of not C given it's B. I'm probably not going to use the formula. So given it's B, that's what it's out of. That's our denominator, which is 0.6. What's the chance of it not being C? 0.54. 0.54 out of 0.6. And I'll just use the calculator to simplify that. 9/10. And one for you to try. So see if you can give this one a go. So I think it's going to be a similar question. We've got A, B, and C, 3 events. We've got the probability of A, the probability of B, the probability of C, and this time we've got the probability of A given B. A and C are mutually exclusive. B and C are independent. So again, A and C can't happen at the same time. So we've got this kind of Venn diagram. We know the probability of A given B, and that's going to be the probability of A and B divided by the probability of B. So I'm just going to work out the intersection. So it's going to be 0.3 equals the intersection divided by 0.5. So half of 0.3 is 0.15. So the intersection of A and B, 0.15. The whole A circle was 0.2. So we've got 0.05. And we know that B and C are independent. So the probability of B, which is 0.5, times the probability of C, which is 0.3, is the intersection, so 0.15. And the whole B circle was 0.5. So we've got 0.15 and 0.15, which is 0.3. We need another 0.2. The whole C circle is 0.3. We need another 0.15. And what does this add up to? So the whole of B is 0.5 plus 0.2, 0.7, 0.3 on the outside. So the probability of B and C, we've worked out 0.15. The probability of C, given it's not A. So which ones are not A? That's all of this. All of this is not A. That's what's given. That's our denominator. It's 0.8. Out of those, what's the chance of it being C? 0.3. So it's 3/8. And that's the probability of C, given it's not A.